The biggest change occurred in generation of electricity in this era is distributed generation DG. The change that anyone would only imagine of is true these days. Yes, it is possible to generate our own electricity. The credit goes to renewables for sure. Customers are able to install rooftop solar plants and generate their own electricity. India has solar insolation in abundant form so that rooftop solar has truly become a boon for users. Various policies launched by government are useful for the end users to install solar rooftop. The basic issue in solar generation is that the generation is intermittent, so the end user might face problems in the nighttime if the solar rooftop is standalone type. The problem can be solved by installing solar rooftop with a battery that in daytime, user uses the solar generation and in the nighttime user uses the power from the battery. However, the rooftop solar with the battery becomes too costly. The problem can be solved by another method, and that is grid connectivity. The solar rooftop is connected with the grid, so that the deficit power can be imported from the grid and the surplus power can be exported to the grid. Therefore, the end user will get the electricity continuously despite of having intermittent generation of solar. Majority of the solar rooftops are grid connected. There are two arrangements defined by governments to design solar rooftop, 1 net metering and 2 gross metering. Let's discuss net metering. In net metering, the electricity generated by solar rooftop plant is adjusted against the imports. Electricity produced by solar rooftop is deducted from the total energy consumption of the user over a period. The adjustments are based on different periods like monthly, bi-monthly, half-yearly or yearly based on the state government policies. Generally, a bidirectional net meter is connected which is able to measure the bidirectional energy like the electricity imported to the user from the grid and the electricity exported to the grid by the user. If the exported electricity is higher than the imported electricity, then the end user may or may not get compensation depending on the state's net metering policy rules and regulations for supplying surplus electricity into the grid. In simple words, consumer may use the energy generated by solar rooftop plant and then may export the excess energy to the grid, and in case of deficit, the consumer will use the energy imported from the grid. Net metering is a system in which power exports are offset by imports, decreasing the electricity bill by deducting electricity generated from total electricity consumed over a set period of time. The adjustments might be made on a monthly, half-yearly, or annual basis. A bidirectional net meter typically accounts for both power import and export. If the exported electricity is greater than the imported electricity, the surplus electricity supplied into the grid may or may not be paid depending on the state's net metering rules. There will be only one bill generated, which will include a total import and total export energy measure. The difference between the two is taken into account, and payment is based on the net amount of imports or exports. Net metering is an arrangement in which electricity exports are adjusted against imports, lowering the electricity bill, such that electricity produced is deducted from the total electricity consumed over a fixed period of time. The adjustment may be done either on a monthly, half-yearly, or annual basis. Typically, a bidirectional net meter accounts for both import and export of power. If the exported electricity is higher than the imported electricity, a consumer may or may not be compensated for the excess electricity being fed into the grid depending on the state's net metering policy. Net metering. The user consumes electricity generated by the rooftop solar system and excess electricity is injected into the grid. For any additional requirement over and above the solar generation, energy can be imported from the grid. At the end of the settlement period, the consumer is only imported from the grid discom the difference between solar energy generated and total energy consumed over the billing period. What is net metering? Consumers utilize the power generated by the solar panels and surplus power is exported back to the grid. In case the customer needs power, when the solar system is not producing energy, such as at night, the customer can import power from the grid. In net metering, a bidirectional meter is used to calculate the total power exported and the total power imported by the consumer. In the case of net metering, the tariff of power exported is the same as the power imported. At the end of the month, the total power exported to the grid and total power imported from the grid is calculated, and based on that calculation, the electricity bill is generated. Generating electricity is easier than ever. Drastic price decline in the last decade, combined with policy incentives for rooftop systems, have allowed consumers to install solar system on their rooftop. However, given that it is expensive to store electricity, systems are often connected to the grid so that surplus can be exported to the grid and deficit can be imported from the grid. Two arrangements are often defined by governments when designing the regulations for solar rooftop system gross and net metering. Gross metering is an arrangement in which a consumer is compensated at a fixed feed-in tariff for the total number of units of solar energy generated and exported to the grid accounted by a unidirectional gross meter and has to pay the electricity distribution company DISCOM at retail supply tariff for the electricity consumed from the grid. The feed-in tariff and retail supply tariff are typically different rates. In gross metering, 2 unidirectional gross meters are installed in the arrangement. One gross meter counts the energy being imported to the end user from the grid and the other gross meter counts the energy exported from consumer to the grid. The consumer is compensated at a fixed feed-in tariff for the energy generated as well as exported to the grid and has to pay the retail supply tariff for the electricity imported from the grid. The feed-in tariff and the retail supply tariff are generally of different rates. Mostly, feed-in tariff is at lesser rate than retail supply rate. In simple words, consumer has to export all the energy generated by rooftop solar plant to the grid and then consume the electricity by importing the energy from the grid. In gross metering, total electricity generated by the solar system is injected into the grid, and consumer imports electricity from the grid for consumption at retail tariff. At the end of the settlement period, consumer is compensated for the electricity exported to the grid at feed-in tariff fit, as determined by the State Commission. What is gross metering? Unlike net metering, the consumer never utilizes the solar power generated as all of the power generated via solar panels is exported to the grid. The consumer has to import all of the power from the grid. Here, 2 different electric meters are used. One calculates the power imported, the other calculates power exported. Also, the rate at which consumers export the power back to the grid is lesser decided by DISCOMs than the rate at which consumers import the power from the grid. And because of this tariff difference, the consumer is only able to lower its electricity bill, but getting a zero electricity bill is out of the scope. Net billing consumers can be paid for net access electricity that is generated and exported to the grid under net metering laws. Net billing is a different way of doing things. End users can utilize net billing to offset retail electricity purchases, similar to net metering. Major difference between net billing and net metering is that different rates are used to value the excess of energy given to distribution companies and energy received under net billing. This means that companies will be able to supply the power generated by rooftops to GRIP at much lower prices, but sell the same at higher costs. This will give distribution companies a higher advantage over the consumers. The minimum solar energy required for consumers under net billing is 1 kW. This following table shows the way solar energy is settled. Relevance and impact. With increasing awareness and availability of new business models, more and more consumers are adopting rooftop solar systems. In the current context, while many distribution companies are inclined to discourage rooftop installations due to potential revenue loss, few have proposed to shift from net metering to gross metering. This is because under the gross metering arrangement, compensation to consumers is typically lower than the retail supply tariff at which they buy electricity from DISCOMs. While, under net metering, since import of power is adjusted against the export, the compensation is effectively at retail supply tariff. Therefore, as a revenue protection measure, they are inclined to adopt gross metering instead of net metering. However, there may be exceptions and consumers should understand the benefit and impact before choosing net or gross metering for their solar rooftop system. Net metering, a comprehensive analysis. 1. Cost effectiveness. One of the primary reasons behind the preference for net metering is its cost effectiveness for consumers. Under net metering arrangements, consumers can offset their electricity bills by generating their own power, effectively reducing their reliance on utility-provided electricity and lowering overall energy costs. 2. Promotion of renewable energy. Net metering incentivizes the adoption of renewable energy technologies, such as solar panels, by making it financially viable for consumers to invest in these systems. By allowing consumers to generate their own clean energy and receive compensation for surplus generation, net metering drives the transition towards a more sustainable energy future. 3. Grid stability and efficiency. Net metering contributes to grid stability and efficiency by decentralizing energy production. Distributed generation from rooftop solar panels and other renewable energy systems reduces strain on centralized power plants and transmission lines, thereby enhancing the resilience and reliability of the grid. 4. Environmental benefits. By encouraging the production and consumption of renewable energy, net metering helps reduce greenhouse gas emissions and other pollutants associated with fossil fuel-based electricity generation. This not only mitigates the impacts of climate change, but also improves air quality and public health. 5. Empowerment of consumers. Net metering empowers consumers to take control of their energy consumption and production, providing them with greater autonomy and flexibility in managing their electricity needs. This increased consumer engagement fosters a sense of ownership and responsibility towards energy conservation and efficiency. 6. Economic growth and job creation. The expansion of renewable energy deployment facilitated by net metering policies stimulates economic growth and creates job opportunities in sectors such as manufacturing, installation, and maintenance of renewable energy systems. This, in turn, contributes to local economic development and prosperity.